Once the cell lysate has been collected and I have aliquoted a little bit for my protein assay, I start getting ready to do my protein assay. I'm using this Pierce BCA protein assay, and it comes with these two reagents that I'm going to mix together. And like everything else that you do, make sure that you have your protocol. For my particular assay, I use the 96 well microplate, and I load in triplicates, so my ladder in triplicates and my samples in triplicates. And so I have here the instructions for my microplate procedure that I use. So really straightforward. I use 10 microliters of my samples that I load into each well of my 96 well plate, and then of the mixture with the protein assay reagent A and B, I will load 200 microliters of that to my 10 microliters of sample, incubate for 30 minutes at 37, and then read at 562 nanometers. Another thing that it's important to have are the, we use BCA, we use actually this albumin standard in order to make our protein ladder. So we have blank buffer, which is our RIPA buffer that we use to lyse our cells, and then these are the concentrations that we use to make our ladder. You can optimize that the way that you want it. And for our albumin standard, it's basically what we dilute. They come in these little ampules that you can see here. And it brings 1 milliliter of 2 milligrams per mil of this bovine serum albumin. Okay, so I'm going to start loading my samples. I'm going to go ahead and get my reagents A and B ready. And this is, once again, we dilute this 1:50 into our reagent A. After loading my protein ladder, I'm gonna go ahead and start loading my actual diluted samples. So starting with my sample 1, and same, 10 microliters of each. So pipette up and down, and then add your 10 microliters to each well. Once I loaded all my samples and protein ladder, then I make the calculations to know how much of the reagents A and B I need for my assay. Here I'm showing the calculations I did for my BCA reagents A and B. So the number of wells that I'm using, it's 60, and I always estimate up. In this case, I added 2 more extra wells to make sure that I don't run out of reagents. So for my reagent A, I do 62 wells times 200 microliters, and so I know that I will use a total of 12 mils and 400 microliters. And my reagent B, I use it at a dilution factor of 50. So divide my total volume of my reagent A by 50. So I know that to the 12 milliliters and 400 microliters, I'm going to add 248 microliters of my reagent B. So I'll go ahead and mix those right now. Now I'm going to mix my reagents. So I have my tube here, and I already have my pipetter ready to go. I have my 248 microliters ready to go. So this is my reagent B. And when you dilute both, when you dilute the reagent B into the reagent A, you're going to note that it changes from a blue color to this light green. So now that this is ready to go, I can go ahead and start loading my 200 microliters onto my 96 well plate, and I already added my samples onto the 96 well plate. So now I'm going to go ahead and start loading my 200 microliters of my reagents A and B mixture onto my 96 well, as you can see here. And make sure that there's no bubbles. My samples have been fully loaded. Now I just shake them a little bit for about a minute, cover them, and now I'm going to go ahead and put them in the 37-degree incubator for 30 minutes, and then I'll be ready to read my plate. So samples have been incubating for 30 minutes or 37, so it's done. I'm going to read it now. Now that my samples have incubated for 30 minutes, I'm ready to read my 96-well plate. I'm using the Biotech Citation 5 imaging reader, and the orientation of the plate goes this way, where the letters A, B, C, all the way to H facing away from you. Once we're ready to read our plate, we're going to go onto our software, the Gen 5 3.10. Open that. And once we are here, go on to where it says read now. Click on read now. And you'll see this window pop out with all our different protocols that we have already written down. I've shown in a previous video how you can read nucleic acid. In our case, we're using this BCA 562 nanometer protocol, so that's the one that we are going to open. Before I click OK, I want to make sure that the setup of the plate matches my setup. I'll check that first. Press cancel. And to check the setup of your plate, you go up here where it says plate layout. Click on plate layout and you'll get this window up here with the blank and the different concentrations of my protein ladder and the samples that I'll be running. So once everything's ready, I can go ahead, and if it matches my samples, then read your plate, or make sure you do the setup based on however is it that you set up and you loaded your samples onto the 96-well plate. So in my case, this works for me. I press OK, and once I come here to the home screen, go onto this green button where it says read a new plate. Click on it and it'll say place the plate on the carrier 96-well plate. Make sure that that's what you have, and use lid. I don't have a lid, so I can remove that, and I'm going to press OK. And just note that my plate is already on that little hand of the machine. I don't really have to do anything. All I have to do is just come here, press OK, and without touching it, it basically pulls the plate in. I don't have to do anything. I'll read, and once it reads, I'll get my results, and I'll be ready to calculate how much protein I have in my samples to run a Western blot. When the run is done, the machine's going to push back out the plate. So there it is. And then you have this window right here. Make sure that you put the name of your experiment and save it. I went ahead and named it sample run. I'm going to save it onto my folder. I have a folder ready to go, and just click on, once you labeled it, click where it says open, or in my case, I'm opening my folder and saving it in there. It's also going to ask if you want your values to be saved in Excel. Press yes. I like that it does this automatically for you, and so it will give you an Excel with your standard curve from your protein ladders, and it gives you the raw reads at 562, your blank, and your concentration. If you don't like this, what I like doing is I like coming onto my software that you see here, These are my readouts, and you can tell it to separate them. For example, if you label all your layouts, you click on layout and then click where it says Excel. And so what it does is that it will only show you this layout. Another thing I like doing is I like going onto concentration, click on concentration, and then click onto that Excel symbol. And so when you come to your Excel, what it does, I'll make this a little bit bigger for you to see. What it does is that instead of putting all the values together, it gives them to you separate. So here we have the well IDs, the layouts. Here in the bottom we have the concentration, and you can do that if you want your raw values that were read at 562 nanometers. Click on, once again, that Excel symbol, and when you check your Excel, you'll see them right here. So this is pretty nice. And now you go ahead and save it, and you're ready to analyze your data and calculate how much protein you have in your samples in order to load onto your SDS page. So let's go over the calculations of how I go ahead and prepare my samples, my cell lysates, in order to denature them. So in this case, I only have 2 samples. I'm working with mice retina cell lysates. On the first one, it's a retina that I resuspended in 50 microliters of RIPA buffer, and in my other sample I used 100 microliters. So I went ahead, did my dilution factors, I did my protein assay, I got my concentrations, my average, and this is actually microgram per microliter, not nanogram. So let me change that really quickly. And then I have my average. Since this is the same sample, I just did 3 different dilution factors. So I have my average. And so right now what I'm going to do is that I want to, for one of my samples, I'm going to prepare 50 micrograms. So that's the total amount of protein I want in my sample. And I want that sample to be in a total volume of 25 microliters, meaning that when I load into the SDS page, I am going to be loading 25 microliters. So the first thing that I do here is, I want equal, if you're doing this in Excel, 50 micrograms divided by your concentration. So in this case, my concentration is 2.9, that's the average. And so it gives me a total volume of 17 microliters. Ahead, in order to get the amount of volume of sample that I need to have a total protein of 50 micrograms for samples. So I do equal, I put 50 divided by, and then what my sample concentration is, which is 2.99, and so that gives me 17 microliters. Once I know the amount of cell lysate sample, in this case tissue lysate sample, then I want to make sure that I have a total amount of 25 microliters that I'm going to be loading. So to do that, remember that we're using also their sample. There's Vortex, Laemmli, and RIPA. For this one, you use 1/4 of your sample. So what I do is, once again, equal 25 5 divided by 4. It gives me 6.5 microliters. So 25 divided by 4, 6.5 microliters. One more time, I'm going to now explain my calculations for my second sample, in which I'm going to prepare 25 microliters that contain a total amount of 40 micrograms per protein. So in order to do that, we do equal 40 micrograms divided by our average concentration, which is right here, micrograms per microliter. So that comes to 10 microliters of our lysate sample will have 40 micrograms. So to this, once again, we want 25 microliters. So what I like doing with Excel, and I'm using the 4x Laemmli. So to our sample, 1/4 should be 4x Laemmli. So I go ahead and type 25 microliters divided by 4. And so 1/4 of that is 6. So let's put here 6. And then in order to determine what our RIPA buffer is going to be, we put equals 25 minus, and so it will be the summation of our sample plus our 4x Laemmli. And so this should give us the total amount of RIPA buffer. So in order to verify that, you can go ahead, put equals to, if you're doing this in Excel, sum, and you're going to get this right here. So you add those 3 values. Okay. Okay. There we go. In this step, I'm going to be preparing my cell lysate samples. So we're going to denature them in order to run them in the SDS page gel. So for that, I basically use the Bio-Rad 4x Laemmli sample buffer. So the first thing that we need to do when we look at the protocol, so very important that you have the protocol for the 4x and not the 2x. So you need to make sure that you have the appropriate Laemmli buffer. So for this, the first thing that I'm going to do is prepare it. So we're going to use 900 microliters of the 4x Laemmli buffer, and to that we're going to add 100 microliters of beta-mercaptan ethanol. So I already have my tube here, and I'm going to go ahead and prepare that. We have our 900. And to that, we're gonna go ahead and add the 100 microliters of beta-mercaptan ethanol. So I already have my pipette ready. If you're sensitive to the smell of beta-mercaptan ethanol, you can go ahead and do this in the chemistry hood. And that's it. Just invert it. And then we have our Laemmli ready to go that we're going to add to our samples. So after we've done our calculations, we're going to go ahead and prepare our cell lysates. So I know that I have here enough to do 2 runs or 2 loads of in my SDS page gel. So I have, in 10 microliters of sample, I have 40 micrograms of protein. So to that, I'm going to add, since I'm doing 2 reactions here, 12.5 microliters of the Laemmli. So 12.5, and that's going to go in here. And then to make sure that our total volume is 25 microliters per reaction, now we're going to fill the rest with our RIPA buffer, which is the same lysine buffer that you use to lyse your samples. For that, we're using 18 microliters. Okay, so here I'm going to prepare my second sample. And so I already did my calculations, which I showed you. And so all I have to do now is add my Vortex Laemmli that has the beta-mercaptoethanol and the RIPA buffer to bring it to the desired volume of 25 microliters per sample per well. So for Laemmli, I'm going to add, for my case, 23 microliters. So mix it. Okay, I have my 23 microliters. Then go ahead and add it. Mix it. And now my RIPA buffer. And for RIPA buffer, I'm only using 7 microliters. So I have my RIPA. Mix it. Vortex quickly, and after vortexing them, briefly spin them down. Now we can go ahead and denature our samples for 5 minutes. Okay, put your sample here, 5 minutes, and we have it at 90.